And today we did lesson 5 of the unit. I mentioned before there's only 9 lessons this unit, so we're already over halfway done. This unit is some calculations, but mostly it's a lot of like knowing your definitions, remembering how to interpret slope, y-intercept, all of that, which is a bit repetitive from unit 2, part 1, because equations is what we're focusing on. But yeah, I don't know. It's just really important stuff, and it's being applied to statistics, so very real world application. We did an additional lesson in math lab, the one where we did estimate the slope and y-intercept. We also saw it today in algebra. So what you need to know is that if you're making a linear model, a line of best fit, a trend line, like they call it all sorts of different stuff, but they all mean the same thing. What should your mind automatically be going to? Linear is a straight line that has what formula? Great. In y equals mx plus b, what usually is replaced with numbers? Well, rise over run, yes, which is what letter? Okay, yes, m is your slope, that's usually replaced with a number. And then what else is usually replaced with a number? And that's your y-intercept. So that is why when we were drawing our line through the middle of our data, we were finding 2 points that appear to be on the line so that we can calculate the slope. And then if we can see the y-intercept, great, just use that. But then we also learned how to calculate that by hand if it's not. Then we also went and added an additional thing. If you have a table of values, then it might just be easier to use them. You still have to know how to do both, because unless you can see every single dot nicely, then you really have to do it by hand to estimate it, which isn't impossible. Like, I don't think it's that hard, but up to you. If you look at the notes online, there are some parts that we didn't do. But if you ever want to practice using technology, here's 5 different data sets that you could practice with. And then the answers for what the lines are shown here. So if you were given this scatter plot, would you be able to tell me what every single dot is? No. And then if you look at like this one, definitely not. There's a bunch that seem to be on top of each other. So that's why you just have to be able to draw a line through the middle and estimate the slope and y-intercept of that line. So yeah, that's what we did. And then you also had to include the part about everyday language, which seemed to be a struggle in 1st and 3rd hour. 4th hour, I presented it a little bit differently, and I think it works better. So rate of change, what's another word for rate of change? Slope. Oops, why am I writing slope again? M is slope / rate of change. Whatever is changing in that real world situation is gonna be your slope. But there's also lots of formulas we use for slope. There's this new one that I mentioned you should memorize by the time the test comes. What else have we used as a formula for slope? Rise over run. And then we've also used change in y divided by change in x. They all are the same thing. So if you have a value for slope, no matter what is going on in the situation, let me think of a random thing. Maybe like hours worked is my x. Maybe money made is my y. If I'm saying that my slope is 23, if it's not written as a fraction, put it over 1. That is my y. So my money made, I'm making $23. for every increment of 1x. So for every 1 hour worked in this situation. Okay. Whatever is going on. Whatever it says on your y-axis, say that for this number for every 1 increment of whatever x. For your y-intercept, by definition, your y-intercept is whenever x is what? Not 1. When x is 0. So if it's your y-intercept, no matter what number it is, that's going to be whenever x is 0. So in this random situation, say your y-intercept is 5. That would be, I make $5 when I work 0 hours. Those would be the random situations, but that's how you interpret it. You still mention both variables, but for slope, it's what it's changing by for every 1x. And for y-intercept, it's whenever x is 0, this is the line. All right, hopefully that helps a little bit. The practice for today that I expect you all to have at least one submission in, preferably at 80% or higher, is 3.05. But otherwise, like, look at your grade. I've been updating the retakes for algebra. See if you might want to consider coming to Saturday Academy. I mean, I won't be there this Saturday because I have a competition, but there's other math teachers that can help you. And then, of course, you could always ask me, this is an extra hour that you have in the retake stuff in here. Be better on some of the math questions that have been passed to you. All of that. All right, if you don't need help with number 2 on today's practice, that's fine. Just continue working quietly and by yourself. Those are the keywords there. And we have a set of data. And it says which equation could be the line of best fit for the data set, and then other questions too. So notice like they didn't give me a scatter plot. I don't like how this is spaced out, so I'm going to eliminate some of these spaces. But if they gave me a scatter plot, then I might try it by hand. But since they didn't and they gave me a table of values, I'm just going to go straight into plugging it into Desmos. So you kind of will learn what methods work best in certain situations. You can really only use Desmos if you have the table of values, which I do. I showed you guys how to put the table in there earlier. How do I do that? Whoop. So what button do I press on my screen? In functions, is there a table? All right, so I don't see it in there. So I know how, but I'm asking you guys so that you guys can remember. How do I put a table in Desmos? What button do I press? Amy? The plus, and then table. All right, keep in mind, I couldn't tell you that on a test. So that's why I'm trying to get you to remember it. From there, you're just typing in your data exactly how it was given to you. Let's see. And then depending on where it is on your scatter plot, you might see the dots right away. You might have to like zoom in and out until you see it. But I copied over my data to make it give me a line of best fit. I need to type in this code. Someone remind me what buttons I press. Sorry, what? How do I make it give me the line? What buttons do I press? We're starting to deviate from it. Definitely make sure you have it in your notes so that you have it for the quiz tomorrow. But here's what it is. It's y1 squiggly mx1 plus b. So it's like y equals mx plus b, but like if you look here, these are x1, y1 right here. This is how you make it attached to the table that you put in. Why the squiggly? I don't know, but that's what creates the line. I once upon a time looked this up in YouTube and it told me, and now I teach you. So you can do that too if you forget. Not on a test though, obviously. So then it tells you what the best slope would be and what the best y-intercept would be right from here. So I'm gonna compare it to my answer options. Which one best matches it? The one with the negative slope or the positive slope? Okay, good. Because it is going down from left to right. Then it says using the equation for the line of best fit for this data set, what does the equation estimate for y when x is 2.3? So using that equation that we said is better, we're going to plug in something. We're plugging in x as 2.3. And then that lets us solve for the y. So wherever it tells you, typically it's not that straightforward. Typically they say whatever the situation is. Like when they sell this many items, what's going to be my output? They say something to that effect. But they want x to be 2.3. So I'm going to, in my calculator, solve that. And the y value that I get is 6.195. So that is my predicted value. Then it says, how does the estimated value compare to the actual value? So actual is always what was collected from the survey or experiment or whatever it is. So compare it to when x was 2.3 over here. My actual was 6.2. My predicted was 6.195. So would you say the results are very close or far apart? Close. They're honestly, if you round it, then it's the same, but yeah, they're close to each other. How does the estimated value compare to the actual value from the table when x is 3? So we didn't solve yet for when x is 3. So let's do that. Now instead of 2.3, we're going to just put 3 for the x. That value is 4.48. That's my predicted value because I used my model to give me it. My actual I get from the table. So look at my actual value when x is 3. We're comparing 3.2 to 4.48. Would you say that the difference in values is relatively small or large compared to the other values? So my actual is 3.2. From my linear model, my predicted was 4.48. I guess it just doesn't want me to write it inside. Compared to like the last one that we did where the values are really close, would you say that these two values are really close? What I think, because it said compared to the other values, like in our table, I think it's gonna say large. That the values are relatively large compared to our other values. Because I mean, yes, in the grand scheme of things, those numbers are not that far from each other. But like the 6.2 compared to the 6.195, like that is way closer. So that is what I'm thinking it'll say. I'll check the key right now. And I am correct. So it just depends what you're comparing it to. Compared to the other values, that difference is pretty large. Questions on that one? Questions on others, if any? Amy? Number 3, lesson 5. All right, so which of these dots are best fit by the linear model? Oh, which of these dot plots are best fit by the linear model? So the model is the line. So the best one will be the one that's through the middle of the data that the points seem to be clustered around it. Your options might be shuffled, so just go based off of my screen. All right, so there's A, B, C, and D. So out of these, which one has it where the data points are really close to the line? B. Ideally, we'd have them all perfectly centered on the line. So the more that it is that way, the better the fit is. All right, questions on this one? Questions on others? Well, then you just let me, could be any other practice from unit 3. Remember, we're over halfway done with the unit, so you should be able to start doing some of your study guide. There's only a few things we haven't covered yet in algebra.